Hello and welcome. This is General Maths TASC 3 for Tasmania, and my name's Tim Grabowski. I have up here on the screen hopefully the questions that you have downloaded from the TI website. These are some past TASC exam paper questions that I aim to get through today, so hopefully you've had a chance to look at those. And it covers the three topics of bivariate data analysis, some sequences and series, and then trigonometry. Out of the 5 topics, they're the 3 that we're going to hopefully get through tonight. Okay, so without further ado, let's kick off. So question 1 here. Let's go through the question and then we'll go through how to attempt this on the calculator. Now, all of these questions, my focus is going to be giving you calculator tips and how to do things efficiently and effectively in a short amount of time. All right, so we have got your typical linear regression question here. We've got the weight of a truck, the load that it's carrying, and the fuel consumption of the truck depending on how much load it is carrying. There is a sample scatter plot being done for you on the right-hand side, and we've got these series of questions to answer here. So the first thing we need to do is find the linear relationship between the fuel consumption and the weight of the load. So the first thing we need to do is get that data into the calculator. So on the calculator, we need to open up a lists and spreadsheet. The easiest way to do that, depending on what page you're on, is just Control and then Doc, which is Add Page. So Control, Add Page. Choose the one we want, so Lists and Spreadsheets. It's important that you give your columns a heading. So my first column is going to be the weight of the load that we're carrying, and my second column is going to be the fuel consumption. And we literally just get the data in off the question. So 0.4, 0.9, 1.6, 1.8, and 2.4. And the corresponding fuel numbers, we had 10.4, 11.4, 13.2, 13.5, and 14.7. We've now got our data entered into the spreadsheet. We now need to do a scatter plot of that data. I'm going to show you 2 ways to get the regression line. So to get the scatter plot, it's Control, Add Page again. This time you want to add a data and statistics plot. That takes us into the statistics side of the calculator. Now, down the bottom where it says click to add variable, we need to choose the correct variable across the x-axis. And if you have a look at the exam paper question, it is the weight of the truck. So the weight of the load goes along the x-axis because that's your independent variable. And along the y-axis is the fuel consumption, because the fuel consumption is your dependent variable. It depends on the weight you are carrying. Now there is your scatter plot, and that should match up with the same scatter plot that they've done on the exam paper there for you. We need to find the relationship between those 2 values. So there's a couple of ways to do this, and I'll show you 2 ways because there are some advantages. We need to add a regression line to this scatter plot now. So Menu, we're going to Analyze, we're going to add in a regression line, so number 6, Analyze, so regression line, number 6, and we want the first one, Show Linear, number 1. And what it does is it puts in the equation of that line of best fit onto the scatter plot. Now, depending on the settings on your calculator, we can also show the R² value. I can't see the R² value at the moment, but if I hit my menu key and go to Settings, I can put on the diagnostics. And if I do that, I now get my R squared value on there as well, and that's very useful for the other parts of the question that are about to come up. Now remember, the Y is referring to the fuel consumption, and the X is referring to the weight of the load that you are carrying. Now another way of getting that same equation is we can go back to the spreadsheet, and we can do it via the spreadsheet. So we go Menu, we're doing some statistics, we're going to do some stat calculations, and we're going to do a linear regression, number 3, linear regression. Now my X values, if I click on that, my X values is what's across the bottom of the graph, and that is the weight of the load. And my Y value is the fuel consumption, because that depends on the weight. And take note here, it's going to save the equation into F1. And this is why this part of the program is useful. It's going to save what we've just done into F1. Okay? And it puts everything onto our spreadsheet for us. And if you scroll down, you can see the different values there. You've got your gradient, 2.2. You've got your y-intercept, 9.5. You've got your R squared value. And you've also got your correlation coefficient there as well too. You can now go back and answer the questions. So on the test paper, it says find the linear relationship between fuel consumption and weight. So if you have a look, your equation is fuel consumption equals 2.2 multiplied by the weight, add on 9.52. So that is our equation for part A. Part B of the question, what is the intercept with the vertical axis and what does it represent? If you have a look at your graph again, where this straight line cuts the y-axis, that is the constant at the end of the equation, that's the 9.52. Now you have to say what that actually means. And what that means is if the weight we were carrying was 0, the fuel consumption would be 9.52 litres per 100 kilometres. So it is the fuel consumption when no load is being carried. Okay? So that's part B. Part C, what is the correlation coefficient and what can you conclude? So if we come back to the calculations that we've just made here, if you take the square root of that R squared value, you will get the R value. Alternatively, it is also in the statistics page here where we did the calculations. There is the correlation coefficient, 0.99806. Now, that will always be a number between -1 and +1. If it's +1, it's a perfect straight line through all of the points. This number is very close to 1. It's 0.998. You probably can't get much better than that. And the way you would interpret that is you would say there is a very strong linear relationship or a very strong correlation between fuel consumption and the weight of the load. And then you would also have to indicate that as the weight of the load increases, your fuel consumption increases. So interpreting that number again, your correlation coefficient, 0.998, there is a very strong linear relationship. As the weight increases, fuel consumption increases. So that's your part C. Part D, use your equation to predict the load if the fuel consumption was 16 litres per 100. So what you are trying to do here is you're essentially trying to solve the equation 16 equals 9.52 plus 2.2x. That was the equation that we had. We're now trying to solve that equation. We can just do that on the calculator. So if we go back to a normal calculator page, we can type in solve, and we can go 16 equals. Now remember we stored this as F1 before. So if I type in F1, it goes bold because there is something stored there. And if I put in X and go comma X, it will solve that equation for the X value. And I get 2.95. So what that means is that if my fuel consumption was 16 litres per 100, the weight of my load would be 2.95 tonnes. And the question says, is this reliable? Now this is an interpolation, extrapolation style question. This question is unreliable because the 16 litres is outside the numbers presented in our data set. The biggest number we have in our data set is 14.7. 16 is bigger than that number. So this answer is unreliable because we are extrapolating. Okay, end of question 1. Let's have a look at number 2. This is a geometric series style question. Let's have a look here. You've got the number of seals in a colony recorded in that table. So year 1, population, etc. What feature of the data indicates the population numbers are decreasing exponentially? Now it's telling you what's going on. It's telling you there's an exponential decrease, but you've got to say why. And if you have a look at the difference in your populations here, from 4,000 to 2,800, we have gone down by 1,200. So we can do that on here. So we've got 4,000, take off, what was the other number? 2,800. So the first decrease was 1,200. And now our second decrease, if we look at the data again, the second number is 1960. The second decrease was only 840. So the first seal population went down by 1,200, but then it only went down by 840. Okay? So what feature of the data indicates that the numbers are decreasing exponentially? The population is reducing by a smaller amount each year. Now, we can also do that graphically as well, and that's what we'll do on the calculator. Now, a good idea is just to clear the current pages that you have or start a new document. Now, I'm just going to clear these pages. So Control, up arrow. Now, if I just delete these other pages, all of those associated problems are now gone. Okay. Now, this time, I've got the year and I've got the seal population. All right, so we get those numbers in again, year 1, year 2, year 3. And our seal populations were 4,000, then they were 2,800s, and then they were 1960. Okay, let's do another scatter plot. So Control, add a page. We're going to add a data and statistics page. Now down the bottom we want the year, and on the side we want the population. And if you have a look at that, that is not a straight line. That is an exponentially decreasing curve if you were to fit a curve through those 3 points. Okay? So, find the common ratio between the terms. Now, to find the common ratio, you need to divide a term by the preceding year. So we're going to start with 2,800, divide by 4,000. So I'm just going to add in a calculator page. Add a page. We've got 2,800 was the second year. We divide that by the first year. And we get a common ratio of 7/10 or 0.7. We do the same thing for the second and third years. The third year was 1960. And we're going to divide that by the preceding year, which was 2,800. And we get exactly the same number again. That is your common ratio. So your common ratio is 7/10 or, as a decimal, 0.7. Okay? All right, we've done part B. Part C, what is the sequence rule? Now, if you have a look on your formula sheet, the sequence rule is Tn equals A times R to the power of n minus 1. That is your geometric sequence rule. So remember, Tn is your nth term, A is your first term, R is your common ratio, n minus 1. And so our rule is going to be our population, P, is equal to the starting number was A, which is 4,000, multiplied by your common ratio, which is 0.7, to the power of n minus 1, where n is the number of years. So that is your geometric sequence rule for part C of the question. What is the sequence rule? So there it is, 4,000 times common ratio to the power of n minus 1. Now, how many seals will there be in year 6? We're going to do this a couple of ways. In the calculator, I am going to put in a new equation for you. So I'm going to add in a page, and I'm going to add a graphs page this time. I'm going to type in that rule that we just had. It was 4,000 multiplied by 0.7 to the power of n minus 1. When you're graphing, though, you can't use n, you have to use x. If we graph that, we can't see it because it's off the page. So if we just do a quick zoom fit, so menu, window zoom, zoom fit, there is our graph, and I'm just going to zoom into the area that we want. Window zoom, zoom box. If I just zoom into the relevant area, that is a graph of how this population is changing. So we're starting at 4,000 and the population is dropping away. Now, how many seals will there be in year 6? The beauty of just having done that equation is if we remember that it's called F1, all we have to do is type in F1 and substitute 6 into that equation. If we substitute 6 into that equation, there is the population of seals in year 6, 672. Now, because it's an application, you've got to round that off to the nearest whole number because we're talking about population. Okay, so 672 seals. Then, part E. During which year will the population be less than 40? Okay, so we want the first time that the population goes to less than 40. So back to the calculator. We want to solve 40 equals F1 evaluated at x, comma x. So what we're doing here is that F1 with the equation that we've got in there, our geometric sequence. We want it to be equal to 40, and we're going comma x to solve it for x. Control Enter. We get 13.9. Now that means 13.9 years. So putting that in the context of the question, during which year will the population be less than 40? That year will be the 13th year. So in the 13th year, the population will be less than 40 for the first time. You would not round that up to 14 years because it's saying in which year, so we want the 13th year. Okay, that's that one done. All right, question 3. Sam's offered 2 different salary schemes. First company, $64,000 with an increase of $2,200 every year. Company B, $50,000, but going up by 12% of the previous year's salary for 8 years. What type of sequence is represented by each company? So the first one is going up by a fixed amount each year. So that is an arithmetic sequence. It's going up by the same amount each year. Company B, it is increasing by 12% of the previous year. That is a geometric sequence. So company A, arithmetic, company B, geometric. Part B, we then have to write down the sequence rule for the salaries offered by each company. Okay, so our first company is company A. So company A, it is an arithmetic sequence. And remember, for an arithmetic sequence, it's the nth term equals A plus n minus 1 times your common difference. So it is salary equals, we were starting with 64,000 and we are adding on n minus 1, which is the number of years, multiplied by the common difference, and we're going up by 2,200. So that would be the rule for company A. And for company B, it is a geometric sequence. So remember, for your geometric sequence, it's A plus, sorry, get rid of that, bit of an error. It's A multiplied by R to the n minus 1. And for company B, our A value is 50,000 multiplied by our common ratio. Now, we were going up by 12%. If you're going up by 12%, it is now 112%. So we have to write 1.12 because that's 112% to the power of n minus 1. And that is your company B geometric rule. Okay, part C. Find the amount earned in the 8th year of working for each company. So, coming over to our calculator. Okay, for our first company, we had 64,000. Adding on, the formula, remember, was 64,000 plus n minus 1 times d. So 64,000 plus, it is 8 minus 1, because we're in the 8th year, multiplied by 2,200. And, excuse me, that is how much you're earning in the 8th year for that first company. The second company, company B, it was 50,000 multiplied by 1.12 to the power of n minus 1, so 8 minus 1. That is how much money you are earning in the second company in the 8th year, $110,534.07. All right. Part D. Find the total earned over 8 years of working for each company. Now, the word total here should give away that we are talking about sum. We are talking about the sum to n terms for each company. All right. So on your formula sheet then, we'll do company A first. Okay. So for company A, the total, we're looking at the sum to n terms of a geometric progression. It is n over 2 a plus L, or the other formula is n over 2, 2a plus n minus 1 times your common difference. Now, given that we know what the last term is, it's probably going to be quicker to use that first formula, so n over 2a plus L. So let's use that one. So our total income is going to be 8 divided by 2 multiplied by a bracket. Now, A, remember, was 64,000 plus, now L was how much money you earnt in the 8th year, and there's our answer there. It's 79,400. Okay, So 79,400. There is your total income for the first company for 8 years, $573,600. Now for the second company, we have a geometric progression. So we've got to use the formula for company B. The total is going to be A multiplied by 1 minus R to the power of N over 1 minus R. That is the formula for the sum to N terms of your geometric progression. And so on the calculator then, we've got, excuse me, so it's A, which was 50,000, multiplied by, now you can use your fraction key, so control divided by, it is 1 minus your common ratio, which is 1.12, to the power of N, which is 8 years, divided by 1 minus your common ratio. Okay, straight into the GP formula. And there is our total income, $614,984 for company B over the 8 years. All right, so that's question 3. Question 4. This is a recurrence equation style question. Mice are being bred for sale. The growth rate is 20% per week. You're starting with 130 mice, and you're selling 35 every week. Write a difference equation which models the situation. Okay, so we've got to write down a difference equation. So remember, a difference equation, again, off your formula sheet, is Tn plus 1 equals, we're going up by 20% every week, so that's 120%, so it's going to be 1.2 times Tn, which is the previous week, and then we are losing 35 mice. So Tn is your current week. We're going up by 20%, so that's why we're multiplying by 1.2, because that's the equivalent of 120%. We're then subtracting 35, because we're losing 35 mice each week. That will give us the following week, which is n plus 1. And you always have to have an initial condition, and the initial condition is that we are starting with 130 mice. So there is your recurrence equation. Tn plus 1 equals 1.2 Tn, take 35, and you're starting with 130. We now have to model this equation on the calculator and complete the table and the graph below. Now, if you have a look, we're doing it for the first 5 weeks. So doing this on the calculator, I am going to start a new page. So I'm just going to delete these other ones so we don't have the same data. I am going to add in a graphs page. Under the graph page, I now want to hit the menu key. I want to go to number 3, which is graph entry edit. Now, you may or may not have done this before. I'm not sure what your teacher's shown you, but you come down to sequence, and we're going to construct a sequence. Okay, so I'll go through that again. It was a graph page, hit the menu, graph entry edit, sequence, and then a sequence. Now, U1 is like T, okay? So we basically have to type in what I've got on the screen here. Tn plus 1 equals, we've got to type that in. So on the calculator, I want you to put a plus 1 in there. So U1 bracket n plus 1 equals 1.2 multiplied by U1 bracket n, because that's the current week. And we are then going to lose 35 mice. Okay, so we're then losing 35 mice. Now, the initial condition was 130. So we're starting with 130. And now your step here is we're going to start at 0 because if you have a look at the table goes from 0 up to 5. And I'm just going to go up to 10 just for the sake of going up to 10. So I've got my Tn plus 1 equals 1.2 Tn, take 35, starting with 130, and I'm going to do it from 0 to 10. Enter. I cannot see it because it's off the screen, but if I do a menu, window zoom, zoom fit, there is my data. Okay? Now, if you have to fill out the table of values, we can trace these points. So if you go menu, trace, graph trace, you are now looking at all of those data points. So here you're starting with 130, then you're dropping down to 121, 110, 97, 81, and 63 for week 5. So those numbers there, you can put into your table, and you literally just copy the graph that you have drawn, that scatter plot, that sequence plot. You would copy and paste that onto the test paper grid that they've given for you. Okay? Part C. When will the breeder be unable to sell 35 mice? So this is looking at the plot here. You currently, in week 5, you still have 63 mice. In week 6, you have 40 mice. In week 7, you have 13.7 mice. So given in week 6 you've got 40, you can still sell 35. In week 7, you've only got 13 mice left, so you can't sell 35. So what's going to happen? In week 7, you cannot sell 35 mice anymore because you've only got 14 mice to start with. Okay, so the answer to part C, week 7. Part D, rewrite the recurrence equation if only 10 mice can be sold each week. Okay, so all that is going to happen there, you are now going to change that 35 to the number 10 because you can only sell 10 mice per week. Plot the remodeled situation on the same axis above. So if we come back to the graph, to get out of the trace mode, just hit escape. Now, to redraw a new plot, we can edit the same one, but I'm actually going to put in a new graph. So if I hit tab, notice how it now says U2, because this is my second equation. So I'm going to put in n plus 1. It's the same equation, so 1.2 multiplied by U2, bracket n, and now I am losing 10 mice, not 35 anymore. I'm still starting with 130, and I still have to change this from 0. Again, I'll go to 10, and then I go enter. Once again, I'm off the page, but if I do a menu, window zoom, zoom fit, you can now see that that red sequence plot is now increasing. There are more mice each week than what you are selling. So the population of mice is increasing. Okay? So part E, plot the remodeled situation on the same axes above. All right, so once again, draw it on the same graph there. Part F, how many mice can the breeder sell if he wishes to maintain a steady population? Now remember, we're starting with 130 mice and we're going up by 20% each week. So on your calculator, if we go Control Add Page, add a calculator, all we need to do is find 20% of the starting population. So 0.2 multiplied by 130, because we started with 130 mice, they're going up by 20%. There are 26 extra mice per week. So that is how many mice we need to sell to maintain a steady state. So part F, how many mice can the breeder sell? 26. It was 20% of the starting population. Write this as a difference equation and plot it on the same graph above. So once again, the only thing that's going to change is we're going to lose 26 mice per week instead of the 35 and 10 that we had before. Now, if we go and plot that again, so coming back to our sequence plot, let's add in a new one. So tab, number 3 we're up to now. So n plus 1, same equation, 1.2 multiplied by u3, brackets n, and we're losing 26 every week. We're still starting with 130, and we're going to go from 0 all the way up to 10. Graph that, and if you have a look, it is now a horizontal line. That is called a steady state. The population of mice is being maintained at the same level all the time. Okay, that's part G done. All right, question 5. This is a Heron's formula question. Now, the TI-Nspire files that you can download from this webinar are available to you, and I'm going to show you what you can download. Okay, so I am going to open up the file, and the file that we're looking at is question 5. Okay, and if you download the TI-Nspire, this is what TI-Nspire file, this is what you'll see. There is your there is a picture of your triangle. Here are the entries for A, B, and C. Here is the semi-perimeter, and here is the area. This is an interactive notes page. Now, you don't need to know much about it. It's all there for you. And if you download it and save it to your calculator, you can use that in an exam situation. Now, if you have a look at the triangle that you've been given, the sides are 17, 10, and 19. Okay? We need to get those numbers in. So the first side is 17. We type it in and hit enter. The second side is 10. Type it in, hit enter. And the third side is 19. You click in the box, type it in, hit enter. Everything is done automatically for you. It calculates the semi-perimeter. It has added all of the values up. Divided by 2, you get 23. It has then used Heron's formula to calculate the area for you, and we got 84.7. So it's as easy as that. That file is there. Download it, save it to your calculator. It is there for you to use whenever you like. Find the area, 87.7, I think it was, 84.7 units squared, centimetres squared. Done. Question 6. Okay, a flight leaves Melbourne. This is one of the shortest distance questions. It's going from Melbourne to Honolulu, travels by the shortest distance, find the distance travelled. Now, once again, this is a pre-prepared file that you are available to download and use. So I'm going to open up question 6. We're looking at question 6. Now, when you download the file, this is what you will see. In the top left-hand box, you've got the latitude and longitude of the different cities. In the top right-hand box, you've got a distance calculation. And down the bottom, you've got a calculation that is working out the angle for you. It does everything automatically for you. All you need to do is enter the lat and long. So, for Melbourne, we are at 38 south, 145 east. So that's minus 38 plus 145. So in the file, we're typing in negative 38 because it's in the southern hemisphere, so a negative for southern, and positive 145 for the longitude because we're in the east. We then jump down to the next one, which is Honolulu. Honolulu is 21 north, so that's going to be plus 21, and 158 west, so that's minus 158. We plug those numbers in. So 21 north, positive 21, and minus 158, because we are in the western side of Greenwich Mean Time. You put those numbers in. The magic of the calculator is it will calculate the angle for you. That is the angular separation on the Great Circle, so 79.6 degrees. And then the calculation up here, because we're working with kilometres and it's a Great Circle, it's 2 pi r. R is the radius of the Earth, 6371. Then it's multiplying by the angle, dividing by 360. And there it is there, 8,854 kilometres. That file is there for you to download and save to your calculator. Once again, you are allowed to use these in an exam. So, find the distance travelled. The distance was 8,854, there it is there, kilometres, 8,854 kilometres. All right, find the flight travel time. Now, flight travel time, we know time is equal to the distance divided by our speed. So we have got, if I open up a new page, add a page, calculator, we had 8,854 kilometres, and the speed of the plane was 880. So distance divided by speed will give us time. Control Enter. Now that's given us a decimal time. We can turn that into hours and minutes by using the degrees, minutes and second key. And if you're not sure about that, hit your little book symbol here. Just above the divided by sign, you've got this little book symbol. That's the library. Click on that and then click tab number 1. And it gives you a list of every built-in command. Hit D and it takes you down to the Ds. And scroll down a little bit until you see DMS. Now that is degrees, minutes and seconds. And what it will do, as soon as you hit enter now, it wants to change your answer into degrees, minutes and seconds. Hit enter, and there it is, 10 degrees, 3 minutes, 41 seconds. Now this is useful, even though it's degrees, it's the same as time. So this is actually 10 hours, 3 minutes, 41 seconds. So your travel time then is 10 hours, and it says to the nearest minute, 10 hours and 4 minutes. Okay, what are the time zones? Your time zones, remember, you just need to divide by 15. So you get the latitude, you get the longitude of each of your cities and divide by 15. So Melbourne, 145 divided by 15. So on your calculator, 145 divided by 15. You are 10 hours ahead of Greenwich time. So it's UTC plus 10. So to write your answer, you'd write Melbourne. So Melbourne is UTC plus 10 hours. It's plus because you're ahead of Greenwich time. Then for Honolulu, it's going to be UTC. So where are we? Honolulu is 158 west. So again, on your calculator, 158 divided by 15. You have to round that off to the nearest whole number. That is 11. It is not 10. It is 11 is the nearest whole number. And it's a minus 11. So we're UTC minus 11. We are 11 hours behind. Now, if you have a look at the difference there, Melbourne is plus 10, Honolulu is minus 11. That is 21 hours difference. And so Melbourne is 21 hours ahead of Honolulu. All right, so there's your time zones. find the local estimated time of arrival. Now, remember from your formula sheet, your ETA, estimated time of arrival, you are leaving at 10 a.m. Monday. You are then adding on your travel time. It's taking you 10 hours and 4 minutes to travel. But then you have to subtract 21 because Honolulu is 21 hours behind Melbourne. Add those times together and you get 11:04 p.m. the day before, so it's Sunday night. So it's 11:04 p.m. on Sunday. Now, I am out of time now. It's 5:45. I had one question left to do. That is available for you to download from the TI-Nspire files as well. You'll see that there. It's not a very long question, but you can download that one to finish off that last sample question. So that is it from me. If anyone has posted any questions, I will hang around for a few minutes and have a look if you've got any questions posted in the chat box, and I am happy to answer those for you. So thank you.